students, welcome to the second semester of Diploma Engineering. In second semester, I am going to teach you applied mathematics. Now, applied mathematics is different for different branches. So, first 4 unit is same for all the branches and then last unit, 5th unit is different for different branches. So, let's start with the common unit, unit 1. Unit 1 is common for all the branches. So, that's why I have written here department as CO, IF, EJ, electrical, mechanical, civil, 2I. Okay. Now, applied mathematics, there are many codes. There are 4 codes. One code is 22201. This code is for civil engineering. Then second code is 22206. This code is for mechanical engineering. Then next is 22210. This code is common for electrical and electronics group. And the last code is 4 times 2, 4. This code is common for computer and IT branch. Okay. So, in all the branches, first 4 unit is exactly same. And so, first we cover this 4 units. So, let's start with unit 1. Unit 1 is differential calculus. In differential calculus, first chapter is functions and limits. Okay, function and concept of limit. So, let's start with function. So, first is learning outcomes. So, after watching this video, students, you will be able to define function. You will be able to explain range and domain. You will be able to define different types of function. You can understand the types of function. Even you can solve the problem based on types of function. And lastly, you will be able to solve the simple problems based on function. So, let's start. So, very first thing is, what is a function? Okay, how can we define this function? So, in simple language, I can say that function is nothing but a relation. Okay, relation between two sets of elements. Okay, so before going through this all mathematical definition, let's see in simple language. In simple language, there are two sets, set X and set Y. Okay, set X are having the set X is having the elements 1, 2, 3, 4. Set Y is having the element A, B, C, D. Okay, so function is a relation between elements of one set with elements of other set. So that means, see, 1, 2, 3, 4 are related with A, B, C, D, right? Where 1 and 4 both are related with B, 2 is related with C, 3 is related with D, right? So, a relation between elements of one set to the elements of other set, that relation is known as a function. Okay, so clear? Function means relation. Okay, in function we are not talking about the single value or single variable. We are talking about the set of values. Okay, there will be a set of values which are related with the set of values. Okay, in particular relation, in particular order, and that particular relation is known as a function. Clear? So, now let's see the mathematical definition of function. So, a function is a process or a relation that associates each element x, small x, of a set X, the domain of the function, to a single element y, small y, of another set y. Okay, possibly the same set, the codomain of the function. Okay, so elements of set X is known as a domain. Okay, elements of set X is known as a domain, and elements of set Y is known as a codomain. Okay, so domain to codomain, that relation is known as a function. Now let's see one more example. So a function is a mathematical process that uniquely relates the value of one variable to the value of one or more other variables. Okay, one variable or many variable. Okay, so function is not compulsory that it is related to only one variable. It may be related to one or more variables. Okay, so function is a input variable. Input variable means X, or independent variable, right? X is a independent variable. Then output variable is a Y. Okay, Y is what? Y is a dependent variable. Okay, dependent variable. X is a independent variable where Y is a dependent variable. So the relation between independent and dependent variable, that relation is known as a function. Clear? Okay, so relation between independent and dependent variable is known as a function. Now this function can be denoted by y or f of x. Y means we are going to define y on the basis of x, because y is a dependent variable, x is a independent variable. So y is equal to f of x, right? Function of x. So either function is denoted by y or denoted by f of x. Now see here, sin x is an example of function where y is equal to sin x, or we can say f of x is equal to sin x. Okay, so sin x is a variable. Same thing, y is equal to e raised to x. Exponential x means e raised to x. Okay, so y is equal to e raised to x, or f of x is equal to e raised to x. This is a example of function. Okay, then this equation, x cube plus x square plus 5x plus 12. So either y is equal to this, right, or f of x is equal to this, right? In both the case, this is known as a function. Similarly, if y is equal to cos x, this is called as a function where x can take any value. X is an independent variable, but once x is defined, x is fixed, y we have to calculate by using the relation y is a cos x. Okay, you got my point? My point is, if y is equal to cos x, then x can take any value, x can be anything, but once x is fixed, then y can be defined by using the relation cos x. Y is a cos x. Okay, so if x is pi, okay, if x is pi means 180 degree. If x is equal to pi, then y will be cos pi, right? Cos pi is -0. Sorry, -1. Cos pi is -1. Okay, so we have to define y on the basis of value of x. Then next is log x. Okay, in means natural log, so log to the base e x. y is equal to this. Then y is equal to 2 root x. Y is equal to cos hx. This h represent the hyperbolic function. Then y is equal to 10x. Y is equal to 10 inverse x. Inverse trigonometric function. Y is equal to x factorial. This sign means factorial. Okay, this exclamatory sign is known as a factorial. So x factorial. All these are examples of function. Now the next concept is range and domain. What is range and what is domain? So the domain of a function f of x is the set of all values for which the function is defined, and the range of the function is the set of all values that f takes. So in simple language, what we can say, that values for x is known as a domain. Okay, all values for x, all elements of x can be known as a domain, right? And values of function or values for y, that is known as a range or codomain. Okay, so see, domain, that is a input, right? Input is what? X. In function, we are substituting the domain and then we are getting output. Output is a range, means y values. Okay, function values. That function value is a range. So simply, x is a domain and y are range or codomain. So with this, I am concluding this video. In next video, we can see the further part of function. So thank you, students.